In March, I was contacted by an editor of Physics magazine. That's an online journal of the APS, the American Physical Society. He asked if I'd be willing to write an opinion piece about whether some topics in physics are too speculative to be legitimate research. He also suggested some topics to consider, for example, string theory, and Avi Loeb's claim that the interstellar object Oumuamua was alien technology. I thought, I'm exactly the right person for this. And you know me, I wrote an honest opinion piece. But when I was done, another editor popped up to say, I paraphrase, that was a little too honest, and they wouldn't run it because it might offend some of their readers. And I said to myself, you know what, I think my subscribers on YouTube will appreciate some honesty. Can physics be too speculative? That's what we'll talk about today. Imagination and creativity are the heart of science. But if you look at the headlines in the popular science media, you can't shake off the feeling that some physicists have gotten ahead of themselves. There's multiverses, dark matter, string theory, fifth forces, and that asteroid, which was supposedly alien technology. These ideas make headlines, but then you never hear of them again, like hundreds of hypothetical particles that were never detected and tests of string theory that were impossible in the first place, or they later turn out to be wrong. All reports of fifth forces disappeared, and that asteroid was probably a big chunk of nitrogen. I've talked about each of these topics previously, so today I want to look at the big picture. Is all this speculation good for something? Is it normal science, or is it in the way of progress? The question how much speculation is healthy differs from the question where to draw the line between science and pseudoscience. That's because physicists usually justify their speculations as work in progress, so they don't have to live up to the standard we expect for fully developed scientific theories. It's then not as easy as pointing out that string theory is for all practical purposes untestable, because its supporters will argue that maybe one day they'll figure out how to test it. The same argument can be made about the hypothetical particles that make up dark matter, or those fifth forces. Maybe one day they'll find a way to test them. So just looking at testability doesn't help. The question we're facing is more similar to the one that the philosopher Lakatos posed. Which research programs make progress and which have become degenerative? When speculation stimulates progress, it benefits science. But when speculation doesn't improve our descriptions of nature, it eats up time and resources and gets in the way of progress. So there's no one-size-fits-all answer to the question what speculation is healthy. We have to make this assessment on a case-by-case basis. Let's then look at some of those cases, starting with dark matter. The original idea of dark matter was a simple parametrization that fit a lot of observations. It was a paradigmatic example of a good scientific hypothesis. However, dark matter has trouble with more recent observations, and physicists in the area have taken on to accommodating data. That means they modify the model after they've seen the data, rather than making successful predictions. Moreover, all those specific particle models for dark matter that physicists have put forward are unnecessary to explain existing observations. They're just adding superfluous details. These models produce publications, but they do not further progress. That we're not making progress with inventing all those new particles is unsurprising, because guessing a specific particle from unspecific observations of its gravitational pull has an infinitesimal chance of working. So lots of speculation that doesn't lead to anything. Particle dark matter is clearly a degenerative research program. Theories for the early universe of fifth forces for dark energy suffer from a similar problem. They do not explain any existing observations. Instead, they make the existing theories more complicated without solving any problem. Again, This isn't healthy speculation, it's a waste of time. It's a strategy that has almost zero chance of working, and it does, as a matter of fact, not work. You don't actually need me to point this out, just think about all the wild ideas that you read about that never seem to pan out. This, too, is clearly a degenerative research program. String theory is a different case. That's because string theory is supposed to remove an inconsistency in the foundations of physics. That's the missing quantization of gravity. If successful, that would be progress in and by itself, even if it doesn't result in testable predictions. Now, string theorists have pretty much given up on their original goal and never satisfactorily showed the theory solves the problem to begin with. You might find that disappointing, but that's how science goes. It doesn't always work out the way you want it to. Much of what goes as string theory today has indeed nothing to do with the original idea of a theory of everything. Instead, string theorists apply certain limits of their theory in an attempt to describe condensed matter systems. Now, in my opinion, string theorists vastly overstate the success of this method, but the research program is progressing and working towards empirical predictions. I'd say it's overhyped, but it isn't degenerative. What's with a multiverse? Multiverse research begins with postulating the existence of entities that are unobservable in principle. This isn't just degenerative science, it's unscientific. The origin of the problem seems to be that many physicists are Platonists. They believe that their math is real, rather than just a description of reality. But Platonism is a philosophy and shouldn't be mistaken for science. So multiverse research has a problem, but it's a different problem. What about Avi Loeb's claim that the interstellar object Oumuamua was alien technology? Loeb has justified his speculation by pointing towards scientists who talk about multiverses and extra dimensions. He seems to think his argument is similar. This, by the way, is an excellent illustration that most physicists never even think about the question what research projects are promising and why. Because if he'd ever actually thought about it, he'd known better than to make this comparison. Loeb's argument about aliens isn't degenerative science, and it isn't unscientific either. It's just bad science. He jumped to conclusions that simply aren't supported by the data. It isn't hard to guess that many physicists would object to my assessments, and that's fine. My intention is not so much to argue this particular assessment is correct, but that such an assessment must be done regularly in collaboration between physicists and philosophers. So that was, in my opinion, piece for the American Physical Society. I actually think I was being very polite. But the second editor finally decided that when they asked for an opinion, they did not want to hear an opinion critical of the community. To say the obvious, ignoring criticism is exactly how groupthink happens. And this episode is a demonstration of just how it happens in physics. The point of my piece was to say, scientists need to regularly assess whether their research methodology is progressive. The APS decided to not even ask physicists to think about what they're doing. For the spoken text in this video, I slightly modified the text I'd written for the opinion piece. You find the original text in the info below. Would that have been too much for physicists to stomach? Let me know in the comments. This video was sponsored by my friend and colleague Brian Keating, who has his own YouTube channel called Into the Impossible. Brian is also a physicist, more specifically a cosmologist. On his channel, he talks about new experiments and theories. Brian's interviewed Nobel Prize winners, billionaires, and an astronaut live from the space station. You might, for example, like his interview with Eric Weinstein and Michael Shermer, or his video Faith of the Physicist about the multiverse as a form of religion. I find his channel both interesting and entertaining, and I can really recommend you check it out. Last but not least, special thanks to our Tier 4 supporters on Patreon. Your support makes it so much easier for us to keep this channel up. And you too can support us on Patreon. The link's in the info below. And you can now also support us right here on YouTube, just by clicking on the Join button underneath this video. Either way you do it, you directly contribute to improving our videos. See you next week.